Welcome to the first lesson of our WireGuard VPN course. In this lesson, we are going to explore the network diagram, the hardware used, and the IP topology or IP scheme. So let's start. As you can see from the network diagram, we have 5 different locations like London office, Berlin office, Paris HQ office, which will work as a VPN server, the home network in Barcelona, and the road carrier, which is currently located in Istanbul. For the ISP, we are going to use a single router with 5 interfaces. The ISP is connected to the internet. The internet is shown as a default gateway here and as a globe. Also, the ISP has a default gateway in the network of 192.168.13.0, which is my home network. The ISP has 6 actually interfaces. One of them is looking to the internet and the other 5 are looking in the direction of the sites, like Paris, like home network in Barcelona, like Berlin office, and like London office, and the road carrier, which is actually can be connected via 4G, 5G, or any other Wi-Fi network, maybe from the hotel or any other location, it doesn't matter. But in our example, we showed it as it is connected to the network of 192.168.20.0/24. So before we continue the scheme, we are going to explore the details of each site. If you look on each site, we have installed one router on each site. Each router has 3 interfaces: London 3, Berlin 3, Paris 3, home office 3, and the road carrier has only one interface. We have used latest RouterOS version 7. Let's see the details. For example, here you can see that I have used one CPU for the London RouterOS and 512 MB of RAM with 4 Ethernet ports, but currently only 3 ports are connected. The same configuration is applicable to all other routers except the Internet Service Provider router, which has 6 Ethernet ports. Next, what I wanted to show you here is that to simulate the real activity, we have used real Windows operating systems. For example, here we have Windows 11 Pro, 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 and here in the Paris office we have used Windows Server 2025 Data Center Edition, so that we can simulate an RDP connection from remote offices like London, Berlin, road carrier, or Barcelona home. The hardware configuration for the Windows 11 Pro is 4 cores and 4 GB of RAM and 1 Ethernet port. The hardware configuration for the server is 8 GB of RAM and 4 cores and 1 Ethernet interface. As you have noticed, each router has a host-only connectivity here, 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 and here. The host-only connectivity for the router provides access to the host machine where the EVNG is installed. We use it to access Mikrotik via MAC addresses from the host machine. Later on other lessons, I will show you that I have implemented ROMON on each of these routers. So I will be able to access all routers from the ROMON, from the central router or ISP router, from totally another machine which just has access to this IP address of this interface Ethernet 1 on the ISP router. As you can see, I have named the routers as London office, Berlin office, Paris office, your home router, and I have named the PCs as London Win11 PC 01, Berlin Windows 11 PC 2, Windows 11 Road Carrier Mobile Client, Windows 11 Your Home PC No Tunnel, Windows 11 Your Home PC Via Tunnel, and Windows 2025 FTP Server. If you explore the topology in the details, you will see that each link was named with its specific subnet. For example, if we look the subnet of the ISP between London office and the ISP you see that the subnet used is 172.16.1.0/24. 16.2/24 was used for Berlin office, and 16.3/24 was used for Paris office, and 16.10/24 was used for your home network office in Barcelona. And for the road variable, for the mobile client, we have used 16.20/24. You can also see that I have mentioned the tunnels which we are going to build with the red color, like tunnel your home Paris, tunnel any location to Paris, tunnel Berlin to Paris, and tunnel London to Paris. If you have noticed, we have local networks in each of the office location. The London office network is 192.168.1.0/24, 2.0/24 in Berlin, 3.0/24 in Paris office. The road barrier doesn't have any network. It is just using the VPN IP. The network in Barcelona has two networks. One of them is 192.168.89.0/24. The other one is 192.168.19.0/24. The 19.0/24 network is going to work via the tunnel of Paris, and then will access the internet also via Paris. The 89.0 network will access internet directly through its ISP interface. In this case, we will have two networks in our home. If you will be connected to left side, you will access internet via your ISP. If you connect with the right side network, you will access your internet via the Paris, so all traffic will be tunneled through the Paris network. If you have noticed on the diagram, I have mentioned here also the tunnel IP interfaces which were used on each location. For example, let's start from the interface which is located on Paris. Its IP address is going to be 10.10.10.1/24. The home network in Barcelona will have 10.10.10.50/24. The road variable will have 10.10.10.100/24. The Berlin office will have 10.10.10.2/24. And the London office will have 10.10.10.3/24. As you have noticed, the ISP router will have interfaces ending with IP address 1 on its side, and the site router locations will have the IP address ending 2/24 on their side. If you also have noticed that the internal networks or local area network on each side will have the gateway interface IP address is going to end with .1 on each interface on each local area network of the router on each side. Okay, now let's discuss what each network will be capable of in each of the office. I will read from the note which I put here so that you will also be able to read it in your lab during your testing. Devices in London will be able to reach Paris LAN and Berlin LAN devices via the tunnel. Internet access will not go through the tunnel. What does it mean? It means that when the device in London will go to the internet, it will go this way. But when devices in London want to reach the Berlin office devices, they will go through the tunnel, will reach the Paris office, will route back to the Berlin office, and will reach the Berlin tunnel in this way. Let's go to the Berlin office. Berlin office devices will be able to reach Paris LAN and London LAN devices via the tunnel. Internet access will not go through the tunnel, so the situation is similar. The Berlin office router will reach the internet with this route, and Berlin office is going to reach the London via the tunnel of the Paris, and Berlin office is going to reach Paris network via the tunnel to the Paris server. Let's see what the Paris site can do. Devices in Paris will be able to reach Berlin LAN and London LAN devices via the tunnel. Internet access will not go through the tunnel. Also, Paris headquarter router will route traffic between Berlin and London LANs through the tunnel. This is what I have told you previously. Let's go to the home network. In home, we will have two networks. We can consider like two Wi-Fi's or two cable networks. It depends how you will implement it on your home. So devices connected to the network 192.168.89.0/24 will not tunnel any internet traffic via Paris headquarters and will reach internet directly via ISP router. So if these devices in this network will try to go to the internet, they will follow direct path to the ISP. Now let's see what path will follow devices on the right side. Devices connected to the network 192.168.19.0/24 will tunnel all their internet traffic via Paris headquarters. So devices which are here will reach the Paris network or Berlin or London network via the tunnel, plus they will reach internet also via the Paris, and then it will go to internet, and then it will go to the globe. Let's analyze the last word barrier. This device will be able to tunnel all of its traffic to the internet via Paris headquarters only with a full tunnel enabled on Windows WireGuard client. With split tunneling, internet related traffic will go directly via ISP. So we will have here two different configurations on the WireGuard client. One of them will have a full tunnel, which will tunnel all the traffic to the ISP and then will reach the internet if necessary, like the network 192.168.90.0 in the Barcelona. And when we will connect to the split tunneling, only the networks which are located in, let's say, London office, Berlin office, and Paris office will be reachable through the tunnel, and all the rest networks will be reachable through the internet. One more important point, that the networks which are located in your home network in Barcelona will not be directly reachable, and these networks will access internet via NAT and access even the VPN network of Paris, London, or Berlin also via NAT. What does it mean? It means that the network 192.168.19.0/24 will not be visible to London, Berlin, or Paris offices. They would know only the tunnel interface of this router, which is 10.10.10.50/24. Okay, this is all what I wanted to show you in this lesson. If you have any questions, you can ask them in the comment section of the video. In the next lesson, we are going to explore the IP address configuration that we have set on each of the router and the client and server devices. See you on the next lesson. I highly recommend subscribing to my YouTube channel so that you don't miss any new lessons or setup guides that I release.